Okay, so today we're going to go over some pretty fundamental concepts that are important to understand before we go any further. So we will go ahead and get started with statistics. So the most fundamental concept, in my opinion, is the notion of the population versus the sample. And this is a concept that surprisingly many people misunderstand. The misconception usually is that a population literally has to be every single person in the U.S. or in the world, right? The population is usually understood in like the literal sense of the word, but that's not the case, right? When we talk about the population in statistics, we're just talking about every member, item, or subject in the group that is ultimately of interest to us, right? So again, it's just every observation or member in the group that we're interested in for our research question. So for an example, if we're interested in studying the sleep habits of all 30 million college students in the US, our goal is to learn more about the sleep habits of all US college students. So our population is all US college students, right? And then our sample in exchange is the subset of these members, items, or subjects from the population that we actually have data for. So in this example where our population is all 30 million college students in the US, we might actually only have data from 10,000 college students in the US who responded to a survey that we sent. So we are only able to collect data from a subset of all college students, and this subset is our sample. As another example, we might be interested in studying the relationship between food intake and calories burned for a specific species of field mouse. In this case, our goal is to learn more about the relationship between food intake and calories burned for all of the field mouse or all of the field mice of this species, but we might actually only have data from an experiment we ran on 230 field mice in our lab. So we're only able to collect data from a subset of all field mice of this species, and this subset is our sample. So these examples both include a population where like we're interested in all college students in the US or all field mice of the species, but it can be something a lot simpler too. It can be our population could be something like maybe all the faculty at one specific university, right? If we're interested in doing a study on the salary data for faculty at UNC Chapel Hill, and we're only interested in UNC Chapel Hill, then our population of interest is just the faculty at UNC Chapel Hill. And a lot of people get tripped up by that and they think, well, no, that would be our sample. No, that's not the case, right? In that instance, it all depends on your research question. If you are ultimately interested in a specific group, then that group is your population, right? And then the sample is whatever you have data from. So it's possible to have data for everybody in the population. So if we think about that faculty salary data example, the population for us of interest was all faculty at UNC Chapel Hill. So if we have data from all faculty at UNC Chapel Hill, then our sample and our population are the same thing in this instance, right? But most of the time, our sample will just be a subset from the population. But I wanted to give an example of how the population can be a much narrower group than how we typically interpret it. And with this distinction between population and the sample is the distinction between parameters and statistics. So a parameter is just a quantity or characteristic that we use to describe the entire group of interest, i.e. the population. So for an example of a population parameter, we might be interested in the correlation between food intake and calories burned for the mice at the population level. And this is for all field mice of that species in this case. So our population parameter is the correlation between food intake and calories burned at the population level, whereas the sample statistic for this example would be the correlation between food intake and calories burned that we observe for our sample of field mice. So in both instances, we're interested in the correlation, but the parameter is that characteristic at the population level, and the sample statistic is the characteristic that we actually observe and compute based on our sample data. So our goal often is to learn about the characteristics of our population, and we quantify these as parameters. So the population level correlation, the population level mean, fill in the blank, right? However, we usually only have access to sample data, and we can quantify the characteristics of our sample using statistics, and then use those statistics as our best guess or estimate regarding the population parameters. And then we also have this notion of descriptive versus inferential statistics. And this is pretty important to understand. So descriptive statistics that's just the use of sample statistics to describe only our sample data set. So there's no mention of the population characteristics yet. We're just describing the sample data itself. This is usually like our first step. So this can include things like bar charts, histograms, scatter plots, summary statistics. Summary statistics are things like the sample average, the sample mean, or sorry, the sample median rather. So the sample average, the sample median, the sample minimum, sample maximum, sample variance, etc. Right? Summary statistics that are specific to just our sample. We're not talking about the population yet. Inferential statistics, on the other hand, are when we take that step from our sample and try to extrapolate and make guesses about the population. So that's when we use sample statistics to draw inferences about the population parameters. And some examples of these are hypothesis tests and confidence intervals. And we'll talk about these more in the videos for those specific topics. But in a nutshell, the question goes something like this at a conceptual level. What is the likelihood of observing our sample statistic that we did observe if this sample data that we're looking at was really drawn from a certain population that has a certain parameter value? And I know that's kind of worded kind of convoluted, but basically it's this idea of we have this sample, we have observed the sample data, we've calculated a sample statistic, and we want to know how consistent our sample statistic that we observed is with some hypothesized parameter value for the population. So as an example, let's say we're interested in studying the average number of hours of sleep per night for all 30 million college students in the US, and we give a survey to 10,000 college students in the US. We hypothesize that students on average at the population level get 9 hours of sleep. That would be our population average, our population parameter of interest. But the average number of hours of sleep for our sample only comes out to 7 hours per night. That's our sample average, our sample statistic. So, how likely is it that our population hypothesis is correct given our sample data? So, our hypothesis that college students get 9 hours of sleep on average, how likely is it that that is correct given our sample statistic, our sample average of only getting 7 hours per night? So, those are the types of questions that we might seek to answer through inferential statistics. And then really quick, I'll go over some notation and symbols you'll see. This notation is used to help distinguish population parameters from sample statistics. So for the mean, the population mean is written as mu, which is how you pronounce this little U looking thing. Whereas for the sample average or the sample mean, it's X bar. You can barely see the bar on top. It kind of got cut off, but there's a horizontal bar going across the X, and you'll hear this referred to as X bar. It's your sample average. The population variance is written as sigma squared, and the sample variance would be a little s squared. The population standard deviation would just be sigma, and the sample standard deviation will be a little less. And then the population size, the number of observations on the population, you might see written with a big N, and then the sample size might be written with a little n. And then some useful symbols in general and statistics that don't generalize to just or aren't specific rather to just the population or just the sample, but are rather more general symbols you might see. The first one is this sigma. I know that there's two symbols called sigma. Not my fault, but we pronounce this sigma, and it just stands for summation or adding everything up. You might see X, which it just stands for the random variable that we denote X, and that can be any variable, like the hours of sleep or the weights of students in a gym class, whatever variable you're interested in, we denote that as x. And then if you see x subscript I, that stands for any individual observation from that variable, and we call it the ith observation. So as an example, if our variable of interest is hours of sleep per night, x equals the hours of sleep per night. Well, x of I is any individual person in our sample, their specific hours of sleep per night. And we would denote this where the first observation would be x sub 1, so that number of hours of sleep per night for the first observation. X sub 2 would be the second observation's value, or the second person's number of hours of sleep per night in this example. X sub 3 would be the third observation value, and then so on and so forth. And so finally, as a quick recap, in statistics, our goal is usually to quantify some characteristic regarding a group of interest. We very rarely have access to the data from every single member of that group of interest, so instead we collect data from a smaller sample of observations from that group of interest, or the population. And once we've collected data, we can use descriptive statistics to describe our sample data, just the sample data, or we can use inferential statistics to make inferences or guesses about the characteristics of the population that we're ultimately interested in. So that's where we extrapolate from the sample statistic to the population parameter. And how do we use sample statistics to draw conclusions about the population? Well, we do that through sampling distributions, which is the topic of our next video. So thanks for watching.